I'm Joyce Kenmont, and today I want to talk to the frustrated mother who posted this elementary school homework assignment online, and to all the other mothers and fathers and grandparents and everybody who's having the same frustrations with homework. This page, I presume, was written by the teacher into a child's notebook, and it's the instructions for how to work these three problems. The mom posted the page because she could not understand the instructions and she was very frustrated about it. The minute I looked at it, I knew exactly what was wrong, not because I'm some brainy mathematician, but just because I have been a homeschool mom since the 1970s, and we do things differently sometimes, and I was familiar with this. The mom who posted this lives in a different state, although I actually do know her and I do see her from time to time. She's a very smart lady. She's a great mom. She has wonderful children. There's nothing wrong with her. The problem is the assignment itself and the way the instructions were written. So let's take a closer look at this page, and we'll start with this first problem here. Here's the first problem in the assignment. 421 plus 367 equals 788. And here are the instructions. Number 1 says write 421 in picture form. Well, what is the picture of a 421? Well, what the picture is supposed to be is the 1 is represented by a dot. Each one is represented by a dot. Each 10 is represented by a line. So this dot is for that, the picture of that 1. For the picture of that 2, we have these two lines. And for the picture of the 4, the hundreds column, we have 4 boxes. The picture for 100 is a box. And then we go to number 2. Write 367 in picture form. So again, we're going to take 7 dots, 1, 2, 3, 4, 5, 6, 7. And then we're going to take 6 bars. And so that one, we already had the 2, so it starts here, 1, 2, 3, 4, 5, 6. And then we have 300s down here. The placement's pretty arbitrary. And then number 3 says, solve by adding the 1s, then the 10s, then the hundreds. Well, you look here at your 1s, what are you going to add? It's just one group of 1s. You look at your hundreds, what are you going to add? It's just a group of 1s, or of 10s, and the same with the hundreds. So what the teacher should have done is separate those two numbers into their own groups, and let me show you how that would look. Okay, here we have the 1s. We have the 421. Here's 1 dot to represent the 1. And then for the 2 10s, we have 2 lines. And then for the 400s, we have 4 boxes. And the other number, 367, is represented by 7 dots, 6 10s, and 3 boxes. Now the child can at least be invited to add. The invitation is there. They may still be in just the counting stage, but at least it is set up as an addition problem. The definition of addition is you have to have at least 2 or more numbers to put together and have a new sum. So this is how it should have been laid out, and hopefully that clarifies it a little bit, but we've got a lot more to talk about. So let's look now at the second problem. Okay, here is the second problem. And this one says 367 plus 239. And here is the dots and the lines and the boxes that the teacher has put out here. Again, not grouped. And here's the last part of the instruction. If there are more than 10, then you cross them off and add to the next place value, which before we went through these two problems you might have found very confusing, and maybe still is. It's ambiguous. If there are more than 10, then you cross them off, the more or the 10. Of course, we know it's the 10. And then you add to the next place value. Well, what do you add? The 10 or the more. So it's poorly written, but here's what happened. The teacher crossed off the 10 right there, and then she circled what was left. So in a way, we now have two groups to add. We have 10 and we have 6, which would be 16, but the problem asked us to add 7 plus 9. That never happens. So again, if it had been written in two groups, it would be easier to understand. So let me show you. I'm going to attempt to write the lines and boxes and so forth, the pictures of the numbers, so that you can kind of anticipate what should go there. So we have 7 ones. So we're going to put 7 dots on this line. I'm upside down and backwards. So I'll try to keep it straight. 1, 2, 3, 4, 5, 6, 7. I like to group in groups of 5 where I can. Okay, now we have 6 tens. So we'll put them here. 1, 2, 3, 4, 5. And I'll put this one down here even though there's room. It's still easier to count. And then we have 300 squares. 1, whoops, that's not pretty good. 2, 300s. And then we go to the next problem. And we have, I have to put this down here a little, 9. So we, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 3 tens, so pretend that's a 1, 2, 3. And then we have 2 hundreds, 1, 2. Right? Did that all make sense to you? Now we have something to add, 2 numbers to add. So we have here 7 and 9. And if the student's able to add that, then I don't know why they're not just doing that, but whatever. So 7 plus 9 is 16, which never would have happened in this arrangement. Well, okay, so we take the 10 and move it up here. So we're going to cross this out and put 1 10 up here, and then we keep the 6. Okay? Does that make sense? Now we have 3 numbers to add. We have a 1, we have a 6, and we have a 3. 1 and 6 and 3 add up to 10. So again, we are going to have to cross this off and move this 10 up to here. So we have a box up here, or this, it's a 100 box. And so we have nothing left, and that's a 0. 0 is empty, it's a placeholder. Otherwise the numbers get confused. And now we have 1 and 3 and 2 hundreds, which will be 6. 600, 606. And there's the answer right there, 606. Would you like to know why your children are drawing dots and lines and boxes? I'd love to show you what they really represent. But for this, we will need a drum roll. And there it is, a 1 centimeter cube represented by the dot your children draw. And here is the 10 centimeter bar that's represented by the line your children draw. And here is the 100 centimeter square represented by the box or the square that your children draw. And there it is. So let's now look at how we actually use these in solving problems. Let's do this problem. And I have a feeling that you would be able to do this without me saying anything here, but let's do it anyway just to be sure. So here we start with adding our ones, And there are different ways that children will want to add them. They might start in the beginning just by counting all the way to the 16 that adds up to. They might do, and this is taught in Common Core, they teach good things. They don't always teach them well. But you might say, okay, we have 7 here, so let's add 3, take them away from this number, add them here, and then we have a 10. And you could do it that way. Or they could just learn 7 plus 9 is 16, and then they would put them down here. And and then when we did this, we crossed it off and left the 6, crossed the 10 off, left the 6, took the 10 to the bank, and the banker trades for a 10 bar. And we put this up here because this is where the child is going to write it when he starts writing his problems. So now we have 1 plus 6 plus 3, 10 bars. And so we're going to add those up in whatever way the child wants to add. That doesn't belong there yet. And so now we have actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bars, which means we're going to go back to the bank and we're going to trade these 10 bars in and come home with a 100 square. And we're going to put it up at the top here, 100 square, and we have 300 squares and 200 squares, and we add that up. 3 plus 1 is 4, 2 more is 6. So we have 600s, and that's where the little marker comes in here to mark that there's a 0 there. There's nothing in that column, but we don't want to forget and just put 6, 6. So we always have to have something there. So 606 is the answer to the problem. Now, the next question is, how many blocks should you have in your home? And I am thinking, after going on the internet, seeing what was available and so forth, that if you had 30 of these, you would be fine. You'll have 100 of these regardless. You'll have, because that's the smallest that they ever put in a set. But 30 of these would be good, 30 of these would be good. And these are easily made out of cardboard. This is just a hollow cardboard, so you buy as many as you choose of those. And in the schools, I don't see them using the thousands, but in your home, you can have a lot of fun with them. So the biggest problem that you would try to work out would be 999, and add it 3 times, or something similar to that. But I wanted to work that out and show it to you so you could see how many blocks that involves using, and that you can do a problem so big that it's actually cumbersome with this many blocks. So I have asked my grandson to demonstrate.
We're going to take the 9 plus 9, which makes 18. And then another 9 makes 27. And we're going to trade the 20 into the bank. And then we will move on to the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're left with 7, and then the next one, we also have 9 plus 9 plus 9. And I'll do the same, and I'm going to try it a different way this time. I'm going to take 1 from this one and make this one a 10. And then I'll take 2 from this one and make this one a 10, and then we're left with 1, 2, 3, 4, 5, 6, 7, 8, 9. because of the 2 extra from the 1s. And then we'll move on to the hundreds, which we also have 9 plus 9 plus 9. And we'll take 1 from this one that makes this one a 10. And 2 from this one to make this one a 10. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have that 2,000s over here. So we are left with 2,997.
We decided to film our grandson at their home because his mother had just bought a set of the plastic blocks, and I wanted you to see them. My own blocks are wood, as you saw earlier. I bought them at least 3 decades ago, and they were much more expensive than the plastic. The whole base 10 block concept has nothing to do with Common Core. It's not their invention. The concept was actually developed by Maria Montessori well over a century ago. Her blocks were made from beads, and they're still being used in Montessori schools all over the world. They're beautiful, but they are extremely expensive, more so than the wood even was. I had spent a lot of time one day online, and I couldn't find a set that I could recommend with just the right configuration of blocks. And I was really frustrated, and then I remembered my friends, the Hunters, who own a homeschool bookstore called Wholesome Books. They've now put together a perfect set of blue plastic blocks with 100 ones, 30 tens, and 30 hundreds, and then you can add all the thousands you want, but they are the most expensive block. But they're all at very affordable prices. And I don't receive any commission. I just want to see happy children. So, and remember also that you can supplement your 1,000 blocks by making some out of poster board. And you could even do some 100 scores if you really felt like you needed more. So we'll put up their contact information here. What is it that makes the blocks work so well? Well, first, it's because they are based on a Montessori principle that says you teach first with concrete materials before you introduce the abstract. That's just common sense, really. So numbers are abstract. Dots and lines and boxes are also abstract. But blocks, beads, buttons, cookies, those are all concrete things. You can see them, touch them, hold them, move them. And if it's cookies, you can eat them. And then you call that subtraction. Also, the blocks are accurate in their proportions. Here's the 100 square, and you can see each of the 100 individual ones in this square. You can touch it. You can feel them. And you can also see the tens, the 10 bars, the 10 bars that make up this block. And in each 10 bar, you can see the individual ones. So that proportional relationship makes it so much easier for the children to understand exactly what they do as they regroup their numbers. When you use these blocks with your children, there is no huge time commitment. You won't be staying up all night with a tearful child. It may take some time to undo damage if there's been damage done, but usually you only need your blocks when your children are needing to learn something new, and then they learn it in maybe a few sessions or maybe even a few minutes, and then once they understand it concretely, they can make the transition to the abstract. And the abstract should probably be numbers. Why draw squares and lines and dots? Once in a while, maybe when you're working on a problem that needs a little review, or it's a word problem and you need to write things out to make them understandable, but basically you would use the numbers. Another reason, and maybe the most important one, that the blocks are so effective is that there are endless possibilities with them, because children can design their own problems. They can make up games. You and your child can challenge each other and make up problems for each other. You can experiment with the blocks if you have a question, a math question, and you want to know, can the blocks work? Can I do this with the blocks? And then you see if you can figure that out. And if you can't, you go online, and there are plenty of tutorials on there. When the students use the blocks on their own and they solve a problem, they manipulate the blocks around, they actually solve a problem, then they are actually making math happen. And that is extremely empowering to them. And if you do want to know what they should be learning in their, to stay up with their class, just go online and search for what a second grader should learn in math, or go to your school and ask them what things need to be learned. So then you can get ahead of the game. I recognize that there are still many excellent teachers in our schools and that many children are doing just fine. My concern is for the ones who are not doing well, and especially in this video for involving math. And parents, you are ultimately responsible for your own children's education. So if they're struggling, please don't wait for the schools to figure out the implementation of what they are now calling messy math. I really highly recommend homeschooling, but wherever your children are going to learn, please get involved and consider getting your own set of blocks. I think you'll be excited when you start using them. And then invite your friends and neighbors over once you've mastered the blocks, because parents and their children invite over, and probably those children are struggling as well. And so show them how simple and fun math can be. I'm going to end this video with a little snippet of a grandson, another grandson. He had never used the blocks much, except just played with them a few times. Then one day he started rolling 5 or 6 dice at the same time, then gathering all the little units that numbered on the blocks, on the dice, and then trading in for tens as he got enough, and then trading the tens in for hundreds eventually. And he just was having so much fun. He worked as fast as he could just on his own and just had a great time. So I asked him one day to play his game again for just a couple of minutes and let us record.
I am rolling dice and seeing what numbers it lands on and getting that many ones and seeing if it'll add up to a 10 bar, and then I get a 10 bar.
There you go. Okay. There's much more that we could talk about, and I will put my contact information up now so that you can send questions or give me feedback or whatever. And thank you very much for watching.